So in the examples of nat64, so I have one side is IPv6 network, other side is IPv4. So if you want to access the IPv4 internet by using the IPv6 network, so you need nat64. So we'll see that how we can do the translation from 6 to 4 and vice versa. So nat64 is available in stateless and stateful. Stateless meaning one-to-one binding is required, and stateful meaning a similar concept like we have IPv4 NAT. So in order to understand this one, I'll take the simple topology with 3 router. So one side will be IPv6 and other side is IP version 4. And IP version 6 RD. So we can see that how we can communicate from IPv6 to IPv4 network. Again, this practical you can do on the minimum 15.4 iOS. So we can see the demonstration. So router 1 belongs to IPv6 network, and router 3 belongs to IP version 4. So this one is nat64. So router 2 will be the nat64 router. So router 1 is IPv6 network only. IPv6 network only. And router 4 router 3 belongs to IPv4, IP version 4 network. So router 2 is connecting these both network. So first I will go for R1 and configure the IPv6. So R1 IPv6 unicast routing interface E00, no shutdown, IP version 6, 2001.10.12:1. And in order to reach to the nat64 prefix, I'm just using the default route, pointing to my next hop IP, which is 12.2. Similarly, I will go for router number 3, which is the IPv4 network. And that one is using the interface E0/1, which is IP address is 10.10.23.3. No shutdown. And this is also using the default route to communicate with IPv4 global network. pointing to the next hop 23.2. So now router 2 is my nat64 router. So first of all, because it is belongs to both, so we need to enable the IPv6 unicast routing as well. Interface E/0 IP. So this is the link going towards R1 2001 10 12 ::2. And the next interface is going towards R3, which is E/1. Sorry, interface E0/1, no shutdown, IP address 10.10.23.2, and subnet mask. So first, I need to decide what will be the nat64 prefix. So there is also the global one also, show nat64 prefix. If I see stateful global. So far nat64 feature is not configured, so global is not visible. So what I will do, I'll go for interface and just enable the nat64 on both. So link is going to v6, link is going to v4. So on both interface, nat64 is enabled. Now if I see global prefix, this one. So this is the well-known global prefix for nat64, ff9v : 96, and the remaining the address will be IPv4 embedded address. So we can also pick on customize. So nat64 prefix, so stateful and stateless. So I'll go for stateful, and the prefix is suppose 3001 96. So prefix length is 96. Now, first of all, what I will do the static NAT configuration. Static NAT meaning the both v4 and v6 can communicate with one another, similar with IPv4 NAT. So for static NAT, there is no access list is required. So bidirectional communication. So nat64, we'll say v6 to version 4, I will say static, and one-to-one mapping 2001 10 10. If I say if traffic is sourcing from 12::1, so it should be convert with my IPv4 source address as 111. So show nat64 translation. So 111 will be the destination for IP version 4 network. And this is the router 1 is going to be sourced from this. So if I ping from R3 to my destination 111, so first I will go for R1. So for router 1 perspective, destination will be the nat64 prefix plus the IPv4 source is embedded. So to say this, IPv6 ICMP on router 1, this is the IPv6 network only. And then from router number 3, this is the IPv4 network. So debug IP ICMP. Debug, sorry, it's debug. Debug IP ICMP. Debug is on. So from router 3, my destination will be 111. So if somebody sending traffic to 111, it should be translated with the IPv6 network. So on R1, so ping 1.1.1, there is no communication. Show run. So interface E0/1. So can I ping 10.10.23.2? Yes, I can ping. Show IP with show IP route. So I have also static route. So no problem from 3 to 2. Then I will go for 2001 10 10 10. So let's see, can I ping here 10? So I cannot ping this destination. This is directly connected from R1. So show run interface E00. The link is in shutdown state. So I'll say no shutdown. Link is up. So then I will go for, so this is IPv6 network. And from R3, that is the IPv4 network. If I ping 1.1.1.1, it's reachable. And you can see the destination is, this is my nat64 prefix, and 32-bit is embedded from IP version 4. So if I ping from here to my destination, so ping is, oops, 2 times. So then I can see, so reply is from 1.1.1. So this is examples of static NAT. So suppose I have one LAN segment on R1 in IPv6 network. So static NAT is bidirectional and one-to-one mapping. So suppose I have one network over here, excuse me, IPv6 address 2001:64. So if I want to ping and make sure router 2 can reach back to this, so IPv6 route : 0 pointing back to 1. So then from router 2, this is the NAT router. So I can ping this network. So from here, if I ping to my destination, this one, from the source address loopback 0, so there is no reachability because there is no the NAT translation for this destination. The similar concept with IP, there is no destination. With IP version 4, so now I need to be configure the dynamic NAT. So for dynamic NAT, first of all, I need to be configure the access list ABC permit. I can permit this network. The destination is any permit 2001 10 10. This network also to destination is any. So B6, the ACL is ABC. So then I will configure the 64 pool. So version pool, the V4 pool is BBC. Let's say I will say 222 start IP 222.23. This is many addresses, although it is accepted. Pool. Then I will say nat64 version 6 to version 4. This time my list name is ABC. Pool name is BBC. And overload if I have more than IPv6 network. So show IPv6, show nat64 translation. This is my static entry. Because now I have the dynamic NAT is configured. So if I source from this one, so now it is reachable to this destination. This is going to be build a session also. So going to 2222. But if I go to R3, destination is 2222, but this is not able to ping back because it is not bidirectional configuration. So this is the examples of nat64.